Speaking about the generalized momenta, the momentum, this can be either translational momentum or rotational momentum, which corresponds to angular momentum. So that is momentum. Momentum is translational as well as rotational. Now this generalized momenta we are calculating from the Lagrangian generalized momenta from Lagrangian. Now for each generalized coordinates, Q, there is a generalized momentum written represented by PQ. Okay, so now here we have Lagrangian L, which is equal to T minus V. That's Lagrangian is a function of Q, the generalized coordinates, the Q dot, which is generalized velocity, and time t. Now the equation of motion for any particular or any generalized coordinates Q is given by total time derivative of dou L by dou Q dot minus dou L by dou Q gives you 0. Now the first term here, this indicates the generalized momentum. This is the generalized momentum. So we can write Pi for any ith quantity, or PQ. The generalized momenta Pi is given by dou L by dou Qi dot. If we are talking about the generalized momenta along x-axis, so it becomes dou L by dou x dot. If you are talking about Py, this will be dou L by dou y dot. So this is how you can write the generalized momentum. And similarly, in the case of polar coordinates, if you need to write p theta, that is the rotational momenta, that is nothing but dou L by dou theta dot, and if it is radial, it is dou L by dou r dot, which will be equal to PR. Now says a small note, what says the equation of motion from Lagrangian, that is d by dt of dou L by dou Q dot minus, you can write I to represent the different coordinates, dou L by dou Qi equal to 0. Now we know that dou L by dou Qi dot equal to Pi, and Pi dot pi dot is equal to dou L by dou Qi. Now this is because from this is equation 1, consider this as equation 2. Now substituting the equation 2 in 1, we get d by dt of, now what is this dou L by dou Qi dot, which is nothing but pi will be equal to or minus dou L by dou Qi equal to 0. Now taking this quantity to the right, we'll get d by dt of pi is nothing but pi dot, which is nothing but the force, is equal to dou L by dou Qi. So this is generalized momenta, and this is the equation of motion. In simplified form, we have this is nothing but the another way of or another form of equation 1. Equation 1 is this, and equation 1 same can be written as pi dot equal to dou L by dou Qi. For example, let's just consider the Lagrangian in Cartesian coordinate system, half m, where m is the mass of the particle, x dot square plus y dot square z dot square minus v of let's say that's for example z. So this is the Lagrangian, and generalized coordinates are x, y and z, and generalized momentum, these are px, py and pz. Then px is equal to dou L by dou x dot, which is equal to mx dot. So this is mx dot. Py equal to dou L by dou y dot, that's equal to my dot. Pz is equal to dou L by dou z dot equal to mz dot. So this is the generalized momentum. Then px dot equal to dou L by dou x, and py dot equal to dou L, and here we have dou L by dou y. Pz, sorry, here we don't have px dot, this is px dot here. So pz dot is equal to dou L by dou z. Now here dou L by dou x, this is with respect to L, that is with respect to x, this is 0 and this is 0, and this is L is equal to v of z, so we have dou by dou z of v of z, and here we need to include the minus v of z, so we'll put it in. So this is pz dot. So there is no force, this implies there is no force along x direction, there is no force along y direction, there is a force which is along z direction. That means that probably the when you consider this Cartesian coordinate system, this is z this is x and this is y, there is gravity which is acting on this particle, which is v of z, which is given by mgz. It's gravity. Here we are introducing a new concept called cyclic coordinates. Now, what is this cyclic coordinate? For example, let us consider Lagrangian, that's equal to half m r dot square less r square theta dot square plus g m by r squared. So this is the Lagrangian of a system. Now, what is the type of the system? System, since it is in r and theta, generalized coordinates are r and theta, that is the plane polar coordinates, then the system is dealing with central forces. That means forces acts along the centers of two objects. This is gravity between two objects. Now similarly we will have electrostatic force, which is again central force, and the force between earth and the sun, which is again the central force. All those forces can be represented in plane polar coordinates. And yeah, so L is given. So generalized coordinates are r and theta. Now what is cyclic coordinate? Cyclic coordinate is that is which is missing. Now here you have r, and corresponding to r there is r dot, right? Now on the other hand there is theta dot, it is present, but there is no theta. Theta is absent. That means Lagrangian is independent of theta, so that is called missing coordinate or cyclic coordinate theta. Okay, now any coordinate, any generalized coordinate qi is said to be cyclic, if Lagrangian is independent of qi. Of qi, which means what? Independent of qi means dou L by dou qi is equal to 0, which means it does not depend on qi. Partial derivative with respect to qi will give you 0. Now writing the equation of motion, we have d by dt of dou L. This is equation of motion with respect to qi. So dou L by dou qi dot minus dou L by dou q equal to 0, or dou qi equal to 0. Now if this qi is a cyclic coordinate, you can write this term, that means the second term in this equation goes to 0, and we can write it as d by dt of dou L by dou qi dot equal to 0. And what about this dou L by dou qi dot? That is nothing but pi. So d by dt of pi equal to 0, which means pi dot equal to 0. So there is no force in ith direction or qi direction. Thus we can conclude that if qi is cyclic, then pi is constant of motion, That means there is no change of pi with respect to time. Momentum does not change with respect to time, means force is 0. Rate of change of momentum is force. So if pi does not change, there is no change in momentum, which means there is no force. So this is called momentum is conserved. Pi is conserved. So what you can say that if qi is cyclic, pi is conserved quantity. So the cyclic coordinates is giving rise to a theorem. So theorem of cyclic coordinates. There is no such theorem regarding the cyclic coordinate, but we will define it in this way. The generalized momentum corresponding to cyclic coordinate is conserved. So let's look into one problem. L is equal to half m x dot square plus y dot square plus z dot square minus mg z. Now generalized coordinates are x, y and z. Now in this cyclic coordinates are, so there is x dot corresponding to x dot, there is no x in the Lagrangian. Corresponding to y dot, there is no y in the Lagrangian, and corresponding to z dot, there is z. So cyclic coordinates are missing coordinates, so it is x and y which are missing, which means the quantities, what are the conserved quantities? Conserved quantities are px and py. Now what is px? Px is equal to dou L by dou x, and py, it's dou L by dou x dot, py equal to dou L by dou y dot. Now these two quantities are conserved because px dot is equal to dou L by dou x, and py dot equal to dou L by dou y. So L is independent of x and y, which means force along this is py px dot. This is how you write. Yeah. So that's conserved quantities. So from here we will understand that is what are the conserved quantities. So it is px and py that are conserved quantities. So what is px? Px is equal to dou L by dou x dot, so which is equal to m x dot, so it's mx dot. And what is py? That is also conserved quantities, that is given by dou L by dou y dot, which is equal to my dot. That means you can write this as x dot, that is velocity along x direction, so m vx, so v, and here you have this is px, and py is the momentum along y direction, so that is py equal to m y dot. Okay, so that becomes mv, that is y, so just indicating that the direction in which the momentum. So momentum along px, momentum along x and momentum along y are conserved. Okay, so momentum along z is not conserved because you have a force along this direction. So with that we are going into a different concept, that conserved quantities. Conserved quantities. Okay, so conserved quantities, the first one, as we have said, it's theorem based on cyclic coordinate. Cyclic coordinates. So that we have seen that generalized momentum, corresponding to cyclic coordinate, to cyclic coordinate is conserved. Now we have Noether's theorem, that is another theorem that indicate the conservation of a particular quantity. So homogeneity of space, if space is homogeneous, then momentum p is conserved. Then this is isotropy of space, that means while rotation the space remains similar, so angular momentum L is conserved. And now we have homogeneity in time, then the total energy is conserved. So in almost all cases we have the homogeneity in space, isotropy in space, and homogeneity in time, which means the momentum, linear momentum, angular momentum, and the energy is conserved. Now, what does this homogeneity of space indicates? It simply says that if there is a space translation, which means x will change to x plus a and y to y plus b or something, or z changes to z plus c, then the system is invariant. There is no change in system quantities except there is a change in the space or the position of the particle. Similarly, if there is a isotropy of space, means space rotation, then along which direction it rotates. For example, we have 3 dimensions. This is z, x, and y. If the rotation is along z direction, the angular momentum corresponding to z is conserved. So this is called the isotropy of space. Then homogeneity in time, which means there is translation in time when this is time translation. That means the system is invariant under time translation. System invariant under this time translation, which means in general total energy is conserved. And here also we need to understand that this will happen only if the potential, that is for the third case, the potential is a function of the position only. Potential is function of position. That means if potential is a function of velocity, then energy need not be conserved. Velocity or time, then total energy won't be conserved, need not be, or dE by dt is not equal to 0. There is some change in energy which cannot be satisfied, that is satisfying the conserved quantity. Understanding the conserved quantities, that is the first one, the total energy. Now if potential energy PE is a function of R, that means the position, then E is conserved. Now if potential energy V of R is a function of, or potential is a function of either Q dot or T, that means the velocity or time, then and total energy is not conserved. So this is another idea. Now coming to the linear momentum, For checking the conservation of linear momentum, we have the cyclic coordinates. It is by checking the cyclic coordinates. That means the momentum corresponding to cyclic coordinate is conserved. Now looking into the angular momentum, this is also given by the potential V. If V is a function of x square plus y square plus z square, then L is conserved. Okay. Now if L is conserved, what about Lx, that means the angular momentum in x, Ly and Lz? What about these quantities? Are they also conserved? Now if it is x square plus y square plus z square, L is conserved. If let's take another example, V is equal to V of x square plus y square plus z square by 2. Now in this case Lz is conserved. Now another example, V of ax square plus y square plus z square, and in this Lx is conserved. Now observing these two quantities, potential, the coefficient of x square or y square or z square determines whether which of these Lx, Ly or Lz is conserved or not. Now in this x square plus y square plus z square by 2, this z square by 2 has different coefficient, so Lz is conserved. In the case of V of ax square plus y square plus z square, x square has the different coefficient, thus Lx is conserved. Now suppose if there is only V of x square plus z square, this means the coefficient of y square equal to 0. So this has got a different coefficient, so Ly is conserved. Now yes.